The Advanced Light Source at Lawrence Berkeley National Lab is home to some of the biggest and smallest numbers in the world. The scientists here require extremely precise measurements and enormously powerful tools to do research on a wide array of subjects. Let's look at some of the extraordinary numbers used at the ALS, as well as several unusual measurements the average person has never even heard of, let alone used. We'll start off with one of the smallest numbers at the ALS, 1/billionth of 1/millionth of a second. This is called a femtosecond, and some users study intricate processes that happen so quickly that only this tiny unit of measurement is appropriate. Next we go up to 10 to the -9th torr. This is the pressure in the storage ring's vacuum chamber, which means there are fewer atoms per unit volume here than in outer space. Bunches of electrons are released from the linear accelerator every 500 millionth of a second, or one bunch every 0.0005 seconds. Approximately 0.2 millimeters by 0.02 millimeters is the size of an electron beam in the booster. This is just about the size of a human hair. 1/2 of all user shift proposals are granted. However, approximately 2/3 of all user proposals are awarded beam time. 0 is the amount of classified research done at the ALS. Everything is available to the public, unlike many other national laboratories. 4 degrees Kelvin, the temperature of liquid helium used to cool many magnets here. This is -452 degrees Fahrenheit, more than 300 degrees colder than the coldest temperature ever recorded on Earth. 10. While it might not seem to be that big of a number, this describes watts per millimeter squared, the approximate heat flux from an undulator beam. This is about as powerful as a rocket nozzle. 99.999994%. The percent of the speed of light electrons reach at their highest velocity. 20,928 square feet. Believe it or not, this is the amount of aluminum foil used at the ALS in 1 year. This huge quantity of foil can be seen covering equipment at the beamlines during bakeouts. 48,000 pounds is the weight of one undulator. These gigantic insertion devices are what make the electron beams as small and focused as they are. 98,000 kilometers is the distance electrons travel in the booster in less than 1 second, or the distance from Berkeley to China and back almost 10 times. 1.5 million revolutions an electron makes around the storage ring in 1 second. Your car's engine only revolves around 30 times per second. $99.5 million was spent to cover construction costs of the current ALS. 1.9 billion electron volts is the energy of the electrons in the storage ring. 4.32 billion kilometers traveled by one electron after 4 hours in the storage ring, which is approximately the distance from Earth to Saturn. 10 to the 19th. Photons per second per millimeter squared per mrad squared per 0.1% bandwidth describes the brightness produced by an undulator. That's 1 billion times brighter than the sun. From femtoseconds to brightness, these numbers and measurements give you some idea of how vast, and at the same time, how precise the science done at the ALS is. While the numbers may seem unrelated, each one contributes to the larger working whole, and if one is off by just the slightest bit, it threatens to throw off everything.